Hello and welcome back to another video. Today we'll be using Terraform and AWS to create EKS node group and clusters within that node group. Here's a diagram of most of the services we'll be using. I have not included things like NAT gateway and security groups to keep the diagram simple, but they will be included in the end project. Here we can see we'll be creating a VPC, and within that VPC a EKS control panel that also has a created IAM user with specific EKS admin policy. This will allow the user to have access to the clusters and other information about them. Let's get started on the Terraform code. If you're going to fork the code from GitHub, feel free to. Just a heads up, I ran into some issues when trying to integrate. You may have to use git bash instead of your normal command prompt or anything like that. But besides that, it should be okay. Should be alright to initialize as I've done here. So first we'll need to establish the providers file. This will include the required version of Terraform and the providers. First, random. For those unfamiliar with random, the random provider allows for some randomness in Terraform configurations, but it's also constrained. It's only random at the creation. Next will be the Kubernetes, then AWS, then local, then no, and also cloud init. Once that's done and saved, within the variables file, we need to define the Kubernetes version. The latest version at this time is 1.30, but I would recommend 1.29. Any less might be out of support by now or by the time you're watching this. Also need to define the VPC, CIDR block, and AWS region. The CIDR block is going to be the standard 10.0/16 and the region US West 1. Following that will be the VPC file. The region will be West 1 as defined in the variable file. Availability zones should have default all available unless we specify others. The random suffix string we want to add at the end of the cluster name. It can be around 8 and specified as not special. The module VPC is going to be referenced from the Terraform AWS VPC, and this should be the latest version at the time, 5.8.1. Name of the VPC is going to be Oakland EKS VPC, and its information, private subnets. Private subnet is the standard 10.1.2.4, but we'll also need another one because we're going to be creating at least 2 minimum clusters. Same with the public subnet, standard 10.4. I'm going to need to enable NAT gateway, single NAT gateway, enable DNS host names and DNS support. Tags are going to be the kubernetes.io with the local cluster name string. Public and private subnet tags are going to be the same with one elastic role balancer each. Now for the security group. We'll need to create rules for both inbound and outbound traffic. So going off the referencing within the Terraform documentation, ingress and egress defined rules in a security group that manages one or more of these rules were added before AWS introduced unique IDs to security groups. So these don't work well in every situation. When you're using the description or the tags attributes, these description and tags attributes rely on the relatively new unique ID. It's also important to note that the protocol equals all or protocol -1 with from port or to port will result in the EC2 API creating a security rule with all ports open. This isn't something that can be controlled or managed through Terraform. With the CIDR blocks, we are going to specify the inbound traffic we will allow. Usually you can use a prefix list and then type that in instead. So you can sort of type in Oakland EKS VPC dot CIDR, I think it's underscore block, and that way you can then reference that within another file instead of typing them all out. But for here, we just want to specify them. Now onto the EKS cluster file. Sourcing the Terraform AWS EKS module version 20.13.1 should be the latest as of this recording. The local cluster name is going to get part of the cluster name from the VPC that we referenced, and then add random strings that we demanded. I'll be able to confirm this after showing around 8 random strings. We're going to also enable IRSA. IRSA is AWS EKS native way to allow applications running EKS pod to access AWS API. So using the permissions we configure within the AWS AIM roles, it'll be able to do that. The tag can be either test or demo. It doesn't really matter for this one. The VPC ID as referenced will come from the VPC file. EKS managed node group configurations AMI type is the Amazon machine image associated with the EKS node group. Instance type will be T3 medium, and VPC security ID will come from the security group file. Managed node group, we're going to have a minimum of 2 clusters within the node group and a maximum of 6, but the desired is going to be 2. This allows us to upscale depending on usage. And also within the 3 resources you see here, this is going to be me trying to create a new IAM user and then attaching the admin EKS user policy to them. It hasn't worked previously, and I've tried a few variations. After this, I'll probably include in the comments of this file actually the variations that I have tried, and probably go through and explain them, what I did and why I don't think it worked. But if anyone has any recommendations or advice as to how I could improve this section, as I think it's the closest I've gotten to actually getting it right, but there's just something missing and I'm not sure what. The cluster name that you see here is interchangeable, and I will change it as soon as the cluster is up and running. After that, I'll then save the file and reapply from Terraform apply. Finally, the output file. Within the output file, the cluster ID will be taken from the EKS cluster file. The cluster endpoint is going to be the endpoint for the EKS Kubernetes API. The security group is the security group we already created and referenced, which is going to be applied to, it's going to be attached to the cluster control panel. The AWS region US West 1 already referenced within the variables or provider. I think it's variables. Yep. Referenced within the variables. And the OIDC provider ARN, which is needed because we enabled IRSA as true. Yeah, as I've added in the description and comments. So let's save all of this and Terraform initialize. You might need to add a Terraform upgrade as well. Okay, so that's initialized, which is great. So then we can Terraform apply. Actually, let me Terraform planet so you can see what's going on, and then I'll Terraform auto approve. Okay, great. So we can see all of the resources being created. You should have this of your own, so I don't need to go through all of them individually. Okay, around 58 resources. Terraform. And while this applies, I'll then take you through it on the console. Okay, so within the console, we can see it's still being created. It's nice that I've got the cluster name, so I'm gonna add that straight away to the... Okay, so this has been created with the expected failure of the EKS admin policy. I'm gonna change the cluster name and see what happens then. But let's have a look in the console. First to just refresh it. Yep, we can see it's activated. We can also upgrade the Kubernetes version. But that should be okay, yeah, because it's still in support for a while. Let me first change the cluster information and then try it again. There should be around 2 to 4 additional resources being created. Should be much quicker. Okay, yep, so only 2. Still failed. Again, I'm not fully understanding why. First, let me just show you how to actually manage the access and create the necessary things. Yep, so once that's been created, I can then go into access and I can see not only the users, but I should be able to see we can also see the settings here, as requested, on demand, 2 nodes, minimum and desired, but a maximum of 6 if needs be. Okay, from that we can see that that's confirmed to be working and the cluster, well, the node groups are up and running. Alright, so now that that's confirmed to be up and running and in a steady state, we can destroy our resources. And with that, thank you for watching. If there's anything else you would like to see, please let me know.